This is a 2023 science physics question. A lot of students find this challenging because there are a lot of information given in the question. You're given that the frictional force due to the air on the object, so this is basically your air resistance or the air drag, on the body gets 4 times larger when the speed doubles. So this is given, so we just take it as it is. And the question makes it very simple because later on the speed is going to increase from 6 and it will double, goes to 12. So you're given that the mass of the object is 4 kg and going through at 6 meter per second, and then it will accelerate to 9 meter per second square, and you're also given the gravitational field strength. Some students actually think of the speed time graph where this is the typical shape of an object falling and with air resistance eventually will reach terminal velocity. So how does all the values relate to the graph? So let's say here is 6 meter per second and the acceleration here due to the gradient here is less steep, which is 9 meter per second square. And where's the 10? The 10 is the initial acceleration when you first release the ball. So over here is 10 meter per second square. And you're going to find if the speed over here is 12, what will be the air resistance? Actually, this graph is not really required. Let's look at the first scenario where the speed of the ball is at 6 meter per second. The ball is falling down in this direction and the weight. Okay, we'll find the weight first. W equals to mg equals to 4 times 10. Actually, the gravitational field strength given to you here is for you to find the weight. And since the ball is falling with an acceleration of 9 meter per second square, you can actually find the resultant force or the net force acting on the ball right now, which is F equals to ma, and your mass will be 4 and the acceleration will be 9, and this will be 36 Newton. So as you know, as it's falling, it has a speed, there's an air resistance. So right now, we are going to find the air resistance when the speed is 6 meter per second. So usually, how do you find? The net force equals to weight minus air resistance. The net force is 36, the weight is 40, which stays constant, and the air resistance right now is what you're going to find. And you can find that the air resistance you minus off, that will be 4 Newton. With this, you can actually just find the air resistance where the speed is 12 because it's given here. Okay, when the speed doubles, the air resistance actually increased by 4 times. So the new air resistance when it's 12 meter per second will just basically be 4 times 4 equals to 16 Newton. So the answer is A. Now let's maybe modify the question to make it slightly more difficult, or maybe for pure physics. So I can also give you that the air resistance is directly proportional to V squared. Instead of telling you in this format, I can tell you the relationship between air resistance and the speed. And actually this is not in the syllabus, but the drag force is actually governed by a formula half times rho. For this case will be the density of the air times the speed of the ball, and the CD here is the drag coefficient. It's a constant, actually depends on the type of surface and the air, and also the cross-sectional area perpendicular to the motion, okay, to the air. So of course all these are constant, that's why you have this relationship. The drag force, which is your air resistance, is directly proportional to V squared. So, and what if I were to say that the speed, what if it's not double, it's not a nice number, instead I can give you 15 meter per second or 20 meter per second, that will be slightly more difficult. But if you know the relationship, you can get the exact value. From the first part of the video, we already found that when the speed is 6 meter per second, the wave is 40, and the air resistance, we established that that is 4 Newton, so I shall not go through again. So using this relationship, I can actually write in this way. And I'm going to have 2 scenarios here. So this is the first scenario. Let's say the speed is at 6 meter per second. Then the respective air resistance will be as such. I put it on the numerator. And this is the second scenario where the speed is 12 meter per second. Now for easy reference, instead of using other values, okay, I will just use back 12, but if it's 15 or 20 meter per second, this method definitely works. So the air resistance, as we said, we established that this is 4 Newton, and the respective speed at that particular time will be 6 to a power of 2, and this is the new air resistance that I'm going to find, and the speed is 12 square. So let's simplify. So this 4 over air resistance that I want to find, this 36 over 144, and if you just solve for it, the air resistance when the speed is 12 meter per second will be the same 16 Newton. So it's good to understand this relationship, especially if they tell you the air resistance is directly proportional to V square, and regardless what speed, it doesn't have to be multiples of the original speed. You can still solve the question easily. All right, thank you.